last video, we looked at the first example of a hypothesis test involving a population standard deviation, and we looked at the hypothesis statements and the requirements and testing the hypotheses. And in the last video, we only covered the classical approach. In this video, we'll continue. We're still on testing the hypotheses, but this time I'm going to go over how to do the p-value approach. So remember that p-value is a probability, and in particular a p-value is the probability of getting the result of a study or something more extreme, assuming that the null hypothesis is true. The first step that you'll take if you're doing the p-value approach for this hypothesis test is to calculate the test statistic. So again, here is the formula for the test statistic. We would put in the values for the null hypothesis standard deviation, the sample standard deviation, and the sample size. Put in all of those values. We would get 10.3054. Now that we have that test statistic, we can calculate the p-value. For this study, the p-value is the probability that a random sample of 20 lenses would result in a sample standard deviation of lens thickness of 3.13 millimeters or less, assuming that the null hypothesis is true, that the standard deviation of the lens thickness with the new technique is still about the same as it was before, still 4.25 millimeters. So notice in the description I said 3.13 millimeters or less. And that phrasing or less, that corresponds to the alternative hypothesis. Remember, this was a left-tail test, and the alternative hypothesis was less than. So everything that we do from here on is going to be in terms of less than. Okay, we'll go back to the p-value. So again, the results of our study, they can also be summarized by this test statistic. So instead of saying all this, that a sample of 20 lenses results in a standard deviation of 3.13, this kind of summarizes that whole result. And therefore, another way to state the p-value would be this way. We could say the p-value is the probability that a random sample of 20 lenses would result in a chi-square test statistic of 10.3054 or less. There's that phrasing or less again, and that has to do with the alternative hypothesis. Since it's a left-tail test and it's less than, assuming that the null hypothesis is true. In symbols, we can write this as the probability that we have a chi-squared value of less than 10.3054. And again, notice that our inequality here agrees with the inequality of our alternative hypothesis. To calculate this probability, you can either use a Casio graphing calculator or a TI graphing calculator. Either way, it might help to sketch out the chi-squared curve. So here's the chi-squared curve. Our test statistic is pretty close to being near the left tail. It's around here. And remember that the left boundary of this region is 0. Always the left side of the chi-squared curve is 0. And then our right boundary is going to be our test statistic, 10.3054. On the Casio calculator, to work this out, you would go to your stat window, go to distributions, which is F5, select chi, which is F3, and then select CCD, which is F2. You want to select var, which is F2, and then you'll enter in variable as your data. The lower bound is 0, the upper bound is 10.3054, degrees of freedom is 19. When you put that information in, it's going to give you the area of this left tail, and that will be your p-value. On the TI 83 or 84, you would hit the second button and vars, scroll down to the function that's called chi-squared CDF. You enter 0 for your lower bound, 10.3054 for the upper bound, and 19 for the degrees of freedom. And depending on your model of the calculator, you may enter it into the function like this with commas. So lower bound, upper bound, and degrees of freedom. Either way, when you do this, the p-value comes out to 0.05499. And to get the result, we'll compare that p-value to the alpha. So again, remember that if the p-value is less than alpha, that means that the results are significant and you reject the null hypothesis. If the p-value is greater than alpha, that means that the results of your study are not significant, and you would say that you do not reject the null hypothesis. For this study, our p-value is 0.05499. Alpha was 0.05. So the p-value is slightly above alpha. And for that reason, the conclusion would be that the study's results are not unusual and not significant. And we would conclude that we do not reject the null hypothesis. So our last step, step 4, state the conclusion. You'll want to state the conclusion in terms of the alternative hypothesis. And so here it is. We do not reject the null hypothesis. That means that there is not sufficient evidence to conclude that the new sculpting technique was effective in lowering the standard deviation of the thickness of the lenses. So this whole phrasing of the sentence is just rephrasing the alternative hypothesis. We're saying there's not enough evidence to conclude that the alternative hypothesis is true. Alright, in the next video we'll take a look at another example of this kind of a hypothesis test.